Improbable, and this talk used to be called Leveraging the DNS for Fun and Profit, but we slightly changed that after the fact. I'm going to talk a little bit about what we consider reactive. Better?
Reset.
Yeah. So yeah, I'm going to talk a little bit about the reactive infrastructure that we have at Improbable. What does Improbable do? We are building software that makes it possible to build complex worlds where you can interact with millions of entities, and it's persistent, real-time, and really freaking awesome. And we call this stuff Fabric, and I'm not going to talk about it. I'm going to talk about the underlying infrastructure that is needed to run Fabric. So that's what I'm going to talk about. Who's on call? I'm on call, Miek Gieben, infrastructure engineer at Improbable, and my team is called Infrastructure, and we're responsible of getting all the machines going. Well, I'm going to tell you what we're all going to do, the logging, monitoring, all that kind of stuff. Fabric is a very dynamic beast. It starts up, knows little about the world, it will ask for machines, it will ask for logging, it will ask for monitoring, and one of the things it will ask for discoverability. And it's our task as infrastructure to make this work out of the box. Another thing, we start many fabrics a day, like hundreds of them. Small, large, they run for a day, they run for a week, they're managed by the users, they're configured by the users, they're named by users, and we all, in some way, need to take care of making this work. So because of the dynamic nature of Fabric, we can't use Chef, Puppet, Ansible, those kinds of stuff. It's also way too manual for what Fabric needs. And the developers are our customers. They have their own requirements. We don't want to deal with them. Sometimes they're really weird. I don't care. I just want to run things completely dynamically. So what did we do? We took a cue from reactive infrastructure. So we want to be flexible, and we don't want to spend a lot of engineering time, excuse me, to make things work. And we also want to do ops light. I don't want to be paged at 3 o'clock in the night and fix something if it can be fixed by itself. So if we need something that like that, we build a service that will fix it for us. Avoid ops at all costs. So what do we use? etcd, of course. SCAR-DNS for service discovery. Simple and works with legacy stuff. Monitoring, we use Prometheus, and we have an elk stack for logging. So this is normal building blocks for making this kind of stuff. The SCAR-DNS is really the heart of the system that makes this all tick. SCAR-DNS service discovery. How does it work? A little bit of detail. We use the DNS. DIG is a tool to actually debug DNS stuff. We have DNS server records. So we have a service called a.improbable.io, and it runs on 3 different machines, or 3 different ports, 9090, 9021, 9073. And the machines, the actual names of the machines are B0, B1, B2. If you want to connect to these, ERDA records. So you connect to 10.10.4.1 at port 9090, and you're connected to the service a.improbable.io. If you know about server records, you can use them as is. And Prometheus knows about server records, and it can just query SCAR-DNS for telemetry star improbable.io, and we'll get all the services that we have running with that globbing name. So if a developer starts up a new fabric and adds telemetry a.improbable.io, we scrape it automatically. There's no configuration going on here, except for setting that name in the Prometheus configuration. So that's all done on the fly. If you don't know about server records, you use A records. And SCAR-DNS will happily translate services back to a record so you can connect to them. So if you want to configure logging in our clusters, we just use the name ingestion.logging and a port number. Easy to remember, that's the only thing we need to configure, and we can use this name across different clusters. So we have one configuration, which is this. And the cross-cluster stuff is the oldest trick in the DNS. The ingestion.logging, we don't use a closing dot, so it will go, when it tries to resolve this name to an IP address, go to resolve.conf, look for search, and then cluster.improbable.io dot, and we'll add that name and make a fully qualified name and connect to that service. Again, we use DNS. This is invented in 1983. Works out of the box. Another thing we get for free, load balancing. SkyDNS will do round-robin replies. So if you query a.improbable.io 3 times in a row, you get the first IP changes every time you get a query. This is poor man's load balancing, but it works well enough for our use case. Another thing, we need to register these names in the DNS, in etcd. And we use short TTLs. So if this name drops out of etcd, the service is probably dead. So this gives us a very simple health signal that the service you're starting doesn't run anymore. A TTL of 10 means every 5 seconds you need to refresh this. We even go one step further, because we used machine names, but Fabric can actually start new modules and other stuff, and it will register those names in the DNS as well. So the whole Fabric stuff becomes discoverable by using the DNS and just loading up names in etcd. Okay, this is cool. How do we do this? We need to put these registrations somewhere. We could use Kubernetes, which we don't use. We don't get good health check info, we think. We could do it on a machine level with another fleet service, which could work, but it's kind of tricky to keep the two things in sync. Or we could put it in a container. But Docker doesn't like multiple processes in a container, which is annoying. So we choose to go the in-container route and run the registration in the container, but we needed to solve the multi-process stuff that Docker doesn't really like. The thing that we run in the container will refresh the DNS registration, and will also do health checks. So either the container dies and the whole thing gets removed from DNS, or the health check fails, and we just manually remove the registration. So I wrote a small init system. The D stands for donkey, because it's really, really simple, or Docker, your choice. And Docker is just an init system. We give them some arguments, and we'll fork those processes. And it has a neat feature that you can submit a process externally to dinit, make it in dinit's control. So if you have a Docker system, a Docker container running, you can just Docker exec into the thing and say run this under dinit's control, which is neat, so you don't have to fiddle with the entry point of the Docker container. You can just do this on the fly. We use Fleet to manage all our jobs, and this is a sample image of how we actually use dinit and the DNS registrations. So we start a Docker, inframon, our monitoring Prometheus, and in the exec post, so when the thing has been started, we also start DNS register, which registers the inframon name on port 1990. If the container goes down, the registration goes down. If DNS register sees that Prometheus is acting funny, it will move the registration, and we know something is not right. Really, really simple tool, dinit, like a couple of 100 lines, if even in Go. So we think this is also pretty neat. What else can we do? We have etcd running, service discovery all works. We know when services don't do their thing. What else can we do? A colleague of mine wrote flagsy, which means you can have flags on the command line and in etcd. So you flip a value in etcd, and the binary notices this and can do fancy stuff with that information. So let's say we have a flag called monitoring_env, and we set it to dev. Fabric starts up, it's development, we don't really care about it. And then at some point the developer thinks, well, it's going to be production. Just flips the flag and awesomeness happens, which I try to depict here. In etcd the flag changes, Fabric picks it up, the scraper, Prometheus, Fabric exports this to Prometheus, Prometheus picks this up, Alert Manager knows how to deal with this flag for setting the alerts. So if it's dev, we don't care about it. If it's QA, we send a Slack announcement. And if it's prod, I will actually get a page. And there is no involvement from ops in any of this, except for handling the page, of course. And all done with the building blocks, etcd, scar DNS, a little bit of D in it, and some other stuff. Other things we get from this, easy A/B testing, just flip flags and so forth. Tuning of parameters, and the last thing I just talked about, the retagging of fabrics in the Prometheus monitoring, which is a really, really, really cool feature, which I don't know anybody doing this. At least I haven't seen it in my career. So I really like that last thing. The stuff we use is mostly open source. My DNS library, DNet, it's on GitHub, really simple. Scar DNS, open source. The flagsy stuff, we have it for Java, Scala, and Go. And we also make contributions to etcd. We added the Prometheus monitoring to it. Fleet. We have several PRs open with Fleet to actually make it scale, which it didn't do before. We have upstream fixes in Prometheus. And the gRPC Go stuff, we added monitoring to that as well, because that's another thing that we use. And if you see something that needs fixing, we will try to fix it. And of course, any questions? Nope.
Don't be shy. Come on.
How do you deal with different versions? How do you deal with versioning of your code?
What version of Fabric?
Yeah.
We don't care about that. That's not our problem. We just run it.
Okay.
So we just get it and we run it. So that's not a problem I have to solve, which is nice. We can, of course, monitor it, graph it, and feed it back to the devs to see what version they have, but that's about it. Okay.
Okay, thank you very much.
Yep, thank you.